Hello everyone. Many times in the questions of the projectile motion, in such situations, we need to obtain the maximum range of the projectile. For that, I am bringing a fantastic trick. Pay attention. In all such cases, the formula for the maximum range will be equal to U multiplied with V and divide by G. I'll be explaining the details. What is the U? The U is the projection speed, the initial speed. Okay. You can see that in the diagram. What is V? V is the final speed, the landing speed, the speed while striking the surface. And G is the acceleration due to gravity. Is it fine? Now, I am obtaining the R max for this case. To obtain the V, we can use the conservation of mechanical energy. As air resistance is neglected, so the mechanical energy will remain conserved. So we can write K initial plus U initial is equal to K final plus U final. Do you agree with this? You can consider this to be the initial situation and this to be the final. Okay. And here on the ground, we imagine the potential energy to be zero. We consider the zero of the potential energy here on the surface. Same will be doing here. On this surface, we'll consider that potential energy is equal to zero. So I'm putting up the data. Initial kinetic energy is visible. If the particle has the mass m, the initial kinetic energy will be written as half m u square. Initial potential energy is 0 as it's on the surface. Final kinetic energy is given as half m v square, and the final potential energy will also be 0. This data gives us that U is equal to V. Do you agree? It means the projection speed and the landing speed are same. Now I have a clear expression of R max in this situation. R max is equal to UV by G. At the place of U, we have U only, and at the place of V also we have the U only. So it is U square by G. I hope you remember the expression for this case. And in this situation, it becomes more convenient and easy. I am using the mechanical energy conservation again. K initial plus U initial is equal to K final plus U final. This is the initial situation and this is the final situation when particle is about to hit the ground. We assume that particle has the mass m. So initial kinetic energy is half m u square. Initial potential energy is mgh. Particle is at a height h above the ground. Final kinetic energy is half m v square. And the final potential energy will become 0 as the particle is hitting the surface. If we simplify, we'll get V is equal to root of U square plus 2GH, an important result. And now we can easily deduce the expression of R max. We know that R max will be equal to U multiplied with V. V is root of U square plus 2GH, and then we should divide it by G. Is it okay? So here we have two beautiful expressions for R max. If you go by the differentiation, write the expression of the R, differentiate it and then maximize the function, that will be a longer route. With this trick, you can save your time. I hope you like this trick. If you want more tricks, let me know in the comment box. Stay awesome. See you again.